Hello students, in the last video you had seen the introduction about the automata theory and computability and the introduction about language and alphabet. So what is the alphabet? Alphabet is a finite set of symbols or characters which are used to define strings for a particular language. So in the today video lecture we are going to see the functions on string and a relation on a strings. So let's move to the functions on a string. The first function that we are going to apply on a string is the length function. To find the length of a string S, we are going to use a length function. So the length of a string S, which we will write as mod of S, is the number of symbols in a S. So what is the output of this length function? The number of characters present in a particular string. And how we are going to write this? Mod of S. Mod of S is nothing but you are finding the number of characters in a particular string. Example, mod of epsilon. So epsilon is nothing but a empty string which doesn't have any symbol. So what is the value returned by this empty string? What are the number of characters present in the empty string? It is 0. So the value returned by this is 0. Take another example. So this is a binary string which is made up of zeros and ones. So how many binary numbers are there? 1, 2, 3, 4, 5, 6, 7 binary numbers are there. So what it return? It return the length of the string is 7 because 7 binary digits are there. For any, suppose you want to find a number of characters, a particular character, how many times it present in the string, then you are going to define the function hash c of s. So hash c is nothing but the character, the occurrence of character you are finding in a string, and what is the s here in the particular string. Okay, so for any symbol c and a string s, we define the function hash c of s to be the number of times that the symbol c occurs in a s. So this function give what? The number of time a particular symbol c occurs in a s. So example, so here I want to find how many times this a symbol occur in a given string, that is a b b a a. And what it returned me? It returned 4. Why 4? Because this a symbol, how many times it occurred in a string? 4 times. So check it out. 1, 2, 3, 4. So what is the output of this? Hash c of s. What output I get? I get 4 because hash c is what is the character here? The c value is a here, and s is what? A b b a is my string. So how many times this a occurred in this string? 4 times. So what it give me? 4. Okay, you can take any example. Suppose if I write hash b, the string is a b b a. Take a same string. So what it returns? So what I am checking here? The occurrence of b in a given string. So how many times b occurred in the string? 2 times. So what it returned? It returned me 2. The next function that you are going to study related to a string is concatenation. The concatenation of two string s and t written as s or t. So s or t or simply st. You can write s or t or a simply st. So it is nothing but what? It indicate what? The concatenation of string s to string t. So st is the string formed by appending t to the s. So s is a one string, t is another string. So if you append t string with a s string, so what you get? You get the concatenation of these two strings. So let's see the example. If x equal to good and y equal to y, when I do the concatenation of x and y, what I get? I get goodbye. So mod of x y is nothing but what? Mod of x plus mod of y. The content of a first string you are going to add with the content of a second string. The empty string epsilon is the identity for concatenation of strings. So suppose you are concatenating epsilon with a string, so what you get? So epsilon x with the epsilon, so x is a one string epsilon is another string, or epsilon with a x. So at the end what you get? You get x only. Why? Because epsilon indicate what? It is a empty string. So no symbols present in that string. So x is what? The string. Epsilon is what? Another string. So if you concatenate x with the epsilon or epsilon with the x, at the end what you get? You get x only. The concatenation has a function defined on the string is associative. So this shows the associative operation on a given string. So here three strings are there for all S, T, W. S is one string, T is one string, and W is a third string. So if you concatenate S, T, then you append that to the W is equal to what? It is equal to what? T, W concatenation with the S. So this is a associative function on a S, T, W string. The next function that you are going to study in the in this topic is the replication function. So we define a string replication for each string w and each natural number I. The string wi is defined as replication means the number of n number of times a particular string w occurs in a language. So if w raised to 0, w is nothing but a string. What is the 0 here? The number of times this string occurs. So here it is occurring how many times? 0 times. So what this string, what are the symbols of this string? It is a epsilon, because it is occurring what? 0 number of times. Next, wi plus 1 is nothing but what? The w string occurs ith time in a language. So example you can see here, a raised to 3. So how many times this a replicates here? 3 times, because the a to the power 3 is there. So 3 times this a replicated in a given language. Next, the second example you can see, by, and how many time it is reflecting? 2 times. So what you get? By. Next here, a raised to 0, b raised to 3. It indicate what? The occurrence of a in the string is 0 time, and the occurrence of b in the string is what? 3 times. So what you get here? 0 time means you will not get a in the string. So what you get here? B 3 times. Next, finally we define a function on a string that is called as a reversal function. For each string w, the reversal of w, which we will write as w raised to r, is defined as, if w equal to 0 means if the string doesn't have any symbols, then w raised to r is what? It is w itself, and what it defines? It defines epsilon, because w, the symbols present in the string is what? 0. So what you get? You get epsilon only. If w is greater than 1, then there exists a for all, there exists a belongs to the summation of, there exists a u belongs to the alphabet star. So alphabet star indicate what? The whatever the alphabet symbols are there, those symbols can occur 0 or n number of times. So what you get here? How the string get defined here? W equal to u a. So u a is nothing but what? Number a is a string. A is a string and u is a prefix of the string. So w equal to ua. The last character of w is a. Then we define w of r equal to AUR, AU raised to r. So there is a one theorem for this concatenation and reversal of the string. Assume that if w and x are the strings, then w, x, r equal to what? See, first you are going to take, see, w and x are the two different strings. So wx indicate the concatenation of two string. Wx raised to r, what if you want to find the reverse of this? So first you are going to find the reverse of x, then you are going to concatenate that with the reversal of w. So for example, name tag raised to r. So name tag raised to, name is one string, tag is another string. So first you are going to take what? The tag reverse, then you are going to concatenate that with the name reverse. So what you get here? Get man. So here the proof is given. The proof is by induction on x. So base case is what? X equal to 0 means what? X is not defining any symbols. Then x equal to what? Epsilon, and wx raised to r. W is one string, x is another string. So x equal to epsilon means it is not defining any symbols. So what you get? You get what? WR only. Okay, so you are going to find the reversal of W, which is nothing but what? Epsilon of WR or epsilon of R or WR. So which is equal to what? X raised to R, W raised to R. Where x is what? What is the value of x here? It is the epsilon. So at the end what you get here? The reversal of W. Suppose if n equal to n is greater than 0 means x is defining some symbols, then W x raised to R equal to what? X raised to R and W raised to R. So first you are going to find the reversal of x, then you are going to find the reversal of W. Okay, so mod x, which defines what? Mod x equal to n plus 1, which implies Wx of R, where x raised to R and W raised to R. Okay, so this is a theorem for concatenation and reversal of the string. Next we see the relation on a string. A string S is a substring of a string T if and only if S occurs continuously as a part of T. So S and T are the two strings. We are going to say S is a substring of a T if and only if S occurs continuously as a part of T. So S is a substring of a string T. When you are going to say it is a substring, suppose it contains the part of the string T. Okay, so let's see the example for this. So A of S is a substring of this. So this is a given string where A is what? The substring of this. So here A are occurring continuously. So A is a substring, AB is a substring, ABB is a substring, or BBB is a substring, or BBA is a substring of a string T. Next, A. So 6 A's are there. It is not a substring of this because the substring should occur continuously in a given string. Here A is there, then A is there. So it is this A are not occurring continuously in a string. So this is not a substring. A string S is a proper substring of a string T if and only if S is a substring of T and S is not equal to T. So here you are finding the substring, not a whole string. So S should contain the part of T, not the string, exactly the string which defines the T. So every string is a substring of itself. So every string is a substring itself by default. The empty string epsilon is a substring of every string. So every string is followed by a empty string. Next, a string is a prefix of T if and only if there exists X belongs to the alphabet star where T equal to Sx. So here the prefix S is always preceded by a given string X. Okay. So a string S is a proper prefix of a string T if and only if S is a prefix of T and S should not be a T here. Okay. So every string is a prefix of itself and empty string is a prefix of every string. So for example, the prefix of A, B, B, A are, see, what are the prefix of A, B, B? A, it may be a empty string. So empty string, why it is empty string? Because every string is followed by a empty string. So empty string is a prefix of this. A may be a prefix, or you can take AB has a prefix, or ABB has a prefix, or the every string itself is a prefix of a string. So ABBA also comes here. A string S is a suffix of T if there exists a X belongs to the alphabet star. So what alphabet star here indicates the number of symbols defining the alphabet can come 0 or any number of times. So suffix is what? T equal to XS. So what is the X here? X is a string and S is what? The suffix of that. So the string S is a proper suffix of string T if and only if S is a suffix of T and S should not be a T. Every string is a suffix of itself. The empty string is a suffix of every string. For example, the suffix of A, B, B, A are what? It may be epsilon, it may be A or BA or BBA, or every string is a suffix of itself. So A, B, B, A is also comes. So this is all about the functions and relation of a strings. So in the next class, we will see how to write a language. Okay, so thank you.